Hey everybody, welcome to the second video out of the rates, ratios, and reasoning unit. This is the second part of the rates part of the unit, and there's only two, so that means we're near the end. It should be shorter than the last one. Last one was 25 minutes long, longer than I wanted, but I'm not there in class with you, so I have to make sure that everything is covered as well. Let's see, so we start off and we have two do now questions. I'll talk about them for a second here, and then I want you to pause the video and get started. So you have both of these together, complete both of them. I will give you a little tip here. This one is if 6 kilograms of apples cost $21, how many kilograms of apples can you buy for 35? This requires you to remember some of the stuff that we did before the break. So you are going to be using, if you remember, equivalent ratios. Equivalent ratios. And what those are two different ratios or fractions that are the same in value. They are the same, like 1/2 is the same as 2/4. They mean the same thing, except one's more simplified than the other. So what you're going to do is you're going to use this information here to create two different ratios using the information that you have again. And there's one piece that's going to be missing, and you need to discover where that is and fill out the rest. And then, since they are equivalent, you have an equal sign here, which means you can perform operations. So remember, when you are dividing, the opposite of division is multiplication, and so on. So you're going to try to get them all to where you have your unknown variable, the x or whatever you want it to call it, and that's going to be at the top, and it's going to be equal to something. All right, and the next do now question, you are just looking at better by, and what I mean by better by is just what is the better value. So I mean, it might be the 27 calculators, it might be the 12. You're looking for how much money you're spending per calculator, and if that doesn't give you a hint that you should be doing unit rates there, then you should probably go back to the other video and review what unit rates are. Okay, pausing the video now and go for it. Okay, so what I did here is I set up what I expect you guys to be able to set up. Some of you may have accidentally put kilograms on top and the money costs on the bottom. Remember that you are usually comparing money per kilogram or money per liter or something like that. So those are common rates. You want to make sure that when you're comparing cash to something else, that cash is on the top. So I did $21 over 6 kilograms. So $21 gives you 6 kilograms. I could find a unit rate from that where however much money is 1 kilogram, but instead I can set it up as equivalent fractions, equivalent ratios, and then I can solve for my x here. So the x is how many kilograms can I get for $35. So I set up the other one. I don't know how many kilograms, but I do know that I have $35. Now here's the solving part, and this is where a lot of people in our class have some issues. Remember that what our objective is to get our x variable here. We want to get it isolated. We want it to be all on its own at the top, equal to something else. So here I'm dividing by x. The opposite of dividing by x is multiplying by x. All right. So I'm going to multiply by x on both sides, because if I do it to one side, I have to do it to the other. So the x's are going to cancel on this, and I'm left here with okay, I meant to get a black one, but that's okay. So I'm going to have 21 times x, and that's over 6 kilograms. And you'll probably be able to skip some steps here. I just want to make sure I'm doing it slow enough that everyone can pay attention. So here I have 21x over 6 kilograms is equal to 35. I probably don't need to keep kilograms in there anymore. So 21 over 6 is equal to, so the opposite of 21 over 6 is 6 over 21. Here I'm skipping a step, but you should notice that if I am doing 6 over 21, the 21s are opposites and they're going to cancel, and the 6s are going to cancel. So that's the same thing as noticing that this is dividing by 6, so I multiply by 6 here, and this is multiplying by 21, so I divide by 21. And they're just going to cancel out, and they're going to leave me x on the bottom. Now I did this to both sides, so on this side I still have 35 times 6 divided by 21. And now all I have to do is work that out, and you're going to see me do that on the calculator over here. So I have 35 times 6 divided by 21, and that gets me 10. All right, and what does the 10 mean? Well, remember our x is how many kilograms, so it's 10 kilograms is what I could get for $35. All right. Hopefully you got that. And the next part of your do now, let's go through that one quickly. It should be a little easier. We're just finding the better buy, so whichever one is more value. I'll start off with A. So 12 calculators for 144 or 27 for 432. Remember, if I'm doing money per item, I am going to put the dollar amount on the top, 144, and I'm going to divide it by 12 calculators. And if I do that calculation, well, that's actually going to be a nice number there. 144 divided by 12 is 12, in case you didn't know, it's a square. So 12 calculators is what I can get for $144 here. Oh, what am I saying? See, this is why you need to keep track of what you're doing. What I meant to say is that it is $12 per calculator. Aha. I got confused with all my 12s. But yeah, $12 per calculator. So if I get 12 calculators, it's 144. Now that makes sense. Way to go, Mystery Mod. And here we have $432.27 calculators. Now, what does that mean? Before I mess this up, I'm going to remember that it's some amount of dollars per one calculator. I'm getting my unit rates. So for every one calculator, it's going to cost however much that is. So 432 divided by 27 gives me 16. So now I look at these two numbers. Would I rather pay $12 per calculator or $16 per calculator? Well, obviously, I would rather pay $12 for every calculator, assuming that they're the same calculator. So the better value is this one. Okay, now part B. Part B says 39 pence for 819 or 11 pence for 341. If you did this, I'm just going to go through it a little bit faster than the other one because it's exactly the same. It's the money per pence. So 819, 8.19 divided by 39 pence means I am paying 21 cents per pen. And the other option was $3.41, and that gets me 11 pence. So let's check the value of this one. 3.41 divided by 11 gets me $0.31, so 31 cents, that's a 1 per pen. So looking at that, would I rather pay 31 cents per pen or 21 cents per pen? I'm going to go with 21 cents per pen, so that would be this guy right here. Okay, moving on. Oh, look, Shania makes an entrance here. So she can plant 12 trees in 38 minutes. I already know that this is a rate, right? Because it's trees per minute. So 12 trees in 38 minutes. That's pretty good, Shania. Can she plant 18 trees in 57 minutes at that rate? So we know what rates are. They're comparing two things. And we also know from older stuff that equivalent ratios help us to tell the difference between two of the similar kinds of things. So we know that the rate is going to be the same. And we're just trying to figure out the unknown. And the unknown is however many trees she can plant. I know it says 18, but we're checking it. We're checking the 18. So we want to actually figure out how many she can plant in 57 minutes if she does it at this speed right here. Okay, so I'm going to set up equivalent ratios. If I can do, or if Shania can do 12 trees in 38 minutes, then we're wondering how many trees, I should call that T instead. I don't know why I deleted everything. T, how many trees can she plant in 57 minutes? Wow, I keep clicking that button. 57 minutes. All right. And this is very much the same as that other problem, and this is all there is to it. You're just going to be doing the same thing again and again. So I noticed that he's already on the top. I wanted to get it alone. So my task here is to figure out what this is. It's dividing by 57. The opposite of dividing by 57 is multiplying by 57. So I'll do that on both sides. This one cancels out. And then I have a real nice multiplication problem to do here, which is 57 times 12 over 38 is equal to T. So if I throw that in my calculator now, let's just do this. 57 times 12 divided by 38 gives me 18. So T is equal to 18. So yeah, it turns out that she actually can plant 18 trees in 57 minutes. 18 exactly. If that had been anything larger than 18, then it would have been good. Oh, I did it again. I gotta get my fingers to stop clicking that button. All right. 57. What am I doing? That was 18. All right, so it did work out, and she can do that. And remember, if it was like 17.8 trees, that would have been a no. If it was greater than 18, like 18.7, that would have been a yes, because she can do at least 18. Okay, we have one about Paul making sandwiches. I guess he's over the break. He got a job at a fast food restaurant. I don't know, did you, Paul? Maybe. He can make 7 sandwiches in 2 minutes. He's very fast. It takes me a lot longer than 2 minutes. How long will Paul take to make 42 sandwiches? Another one with a rate. So he's making 7 sandwiches per 2 minutes. And we want to know how many he can make, or how long it would take him to make 42. All right. So 7 over 2, 7 sandwiches per 2 minutes, is equal to 42 sandwiches in however many minutes. I'm going to put T there for however many minutes it takes him, how long. And then we just solve. The very same process. So I want T to be at the top on its own. I'm dividing by T here, so the opposite of dividing by T is multiplying by T. So now if I rewrite this, I have 7T over 2 is equal to 42, because it was cancelled. Now, what am I going to do here? Well, the T is not on its own, so I need to look at what's the opposite of multiplying by 7 and dividing by 2. Well, that's dividing by 7 and multiplying by 2. Right. So I can just flip that fraction and it works out. And I do that to both sides. These cancel out. And then the other one, the other side is just 42 times 2 over 7. What does that get me? That gets me 42 times 2 divided by 7, 12. Apparently, it takes Paul 12 minutes to make 42 sandwiches. Alrighty. Find the unit rate of the examples below. Yeah, they look a little familiar, don't they? I think I messed up and I put them in there twice, but it's good practice. So I'm not going to do this so that the video is a little shorter, but remember, you do need to know how to do all these things. So if you did it with me last time, then try doing this on your own and checking your answers again. And remember, some of them are tricky, like, I don't know, was it this one? And I don't know, something else where they were flipped. Just remember the common rates: kilometers per hour, dollars per something. And if it's bulk, like gummy bears, it's per 100 grams, because that's what we like to do. It's a little easier than 0.003, that kind of stuff. All right, the next section in your packet, I am going to just have you pause the video and read through these on your own. You don't need me to read for you. You are fully capable of reading, I think. So you just read about rates and read about unit rates, and there's a couple things here that we can look at too. Did I plan on doing that? I don't think I planned on doing that, but we'll take a quick look. So go ahead and read that stuff and just look at these and try to answer them if you can. Okay. Okay, so looking at these communicate the idea problems here, they're not so bad. Give an example of a ratio using words and numbers from the table. So using words, I would probably, we got birth mass of bear, black bears and polar bears, and then the mass after 60 days. Okay, a ratio, 0.3 to 0.7 as a number, and that as words is comparing the birth mass of a black bear to the birth mass of a polar bear. Sure, I could have done a lot of different ratios there. A rate, though, is the same thing, kind of like a speed or how something is changing. So here we are looking, for example, at like black bears. From the 0.3 after 60 days, it becomes 6.5. And for polar bears, they went from 0.7 to 7.4. So I could look at it like how many kilograms per day did they gain, or I don't know. That's probably a good one. So we know 60 days and we know kilograms. Yeah, we could just do that. So yeah, I would probably do like 6.5 minus 0.3, so that's 6.2 kilograms in 60 days. And I could solve it for a unit rate, and that's what I'm going to do in part C. So I've got this 6.2 divided by 60 days, and as a, we've done this, as a unit rate, all I do is make it per 1 day, and I do that by just dividing it. So 6.2 divided by 60 gives me 0.103 repeated per 1 day. I just write per day. There we go. And that's in kilograms. Not a very nice number. I could probably just put it in grams and it'd be prettier looking, but the point is there. So it's per 1 day. Unit rate. Number 2, 2 brands of canned dog food are on sale. Assuming the cans are the same size, brand A costs $13.60 for 8 cans, and brand B costs $8.75 for 5 cans. Explain how to find the unit price for brands A and B. Explain how unit prices help you compare the cost of dog food. Thankfully, I don't have to solve this one for you. We just have to explain it. So what I would do is I would divide 13.6 by 8, because that tells me the cost per 1 can. And if I know the cost for 1 can of brand A, and I do the same thing for brand B, and I know the 2 different brands, what each can costs, well, the unit price now tells me which one is more expensive per can. That's pretty useful, especially in real life. Okay, number 3. Give 2 examples of rates that are common in everyday life. Share your examples with a classmate. Yeah, and we had a whole page full of that stuff right before this. So beats per second, beats per minute, speeds, meters per second, kilometers per hour, typing, words per minute, cost of something per item. You know, there's so many examples of rates that you could use here. What units measure in each of the rates in part A, I just said them out loud. And explain why rate cannot be expressed as a percentage. Well, why can't it be expressed as a percentage? If you are doing if you're doing like $5 per one calculator, how do you get a percent of that? That doesn't, I don't even know how to explain that, because that doesn't really make sense. Percentage, percent means per 100. So you're just taking a single number and you are changing the decimal points so that you can express it in an easier way. Like 0.01 in percent is, you know, you move the decimal places 2 over, so you get 1, and that's 1%. So yeah, percentage doesn't really allow you to compare two different things like dollars to calculator, just for a single number that you're trying to express differently. Wow, this is taking longer than I thought, but thankfully we're pretty much at the end here, and it is the last video of rates. Thank goodness. Okay, calculate the fuel efficiency of each car. Show your work. 1 mark each. This actually used to be on a test, I think. So hint, hint, it might come back. I don't know. It says for step 1, calculate the liters of fuel used per kilometer. So liters per kilometer. Liters per kilometer. Give your answer the nearest 10,000th. If you don't remember what that is, remember this is 0. Here's your 10th, here's your 100th, and here's your 1,000th and 10,000th. So 4 things after the 0. 10, 100, 1,000, 10,000. Okay, so we're probably going to get a really ugly number. That's the point made here. For step 2, multiply the unit rate by 100, round to the nearest hundredth. So you should be able to figure that one out here. All right, and if I were you, I would normally use that other technique when you're doing per like 100 grams or 100 kilometers, because it's just easier. But going to the unit rate and then multiplying by 100 to change the denominator is a very good way to do it as well. All right, stop talking and more solving problems. So unit rate, we're calculating for step 1, we do liters. So we did 45 liters here is what was used by car A, and car A went a distance of 639 kilometers. Now we're converting that into a unit rate, so we want how many liters per 1 kilometer. That's going to be super ugly because it's a small number divided by a big number, but let's see what it is. All right, over on the calculator we have 45 liters divided by 639 kilometers. Yep, 0.7, no, 0.07. Wow. 0.0, I almost did it again, 0.704. So I said to the 10,000 spot, so there we are, 0.0704. Okay. And that is liters per kilometer. I'm running out of space. If I'm multiplying it by 100, what happens is there are 2 zeros in 100, so I move the decimal place 2 spots. So it ends up being 7.04 liters per 100 kilometers. Okay, next one. 80 liters over 688 kilometers. And that's going to be a beautiful number as well. 80 divided by 688 gives me 0.4 116 to the 4th spot. I'm getting 627 on the calculator, so I need to round up. That's 1163, not 1162. I'm rounding up there. And that again is liters per kilometer for the unit rate for 1 kilometer. And here in step 2 I want per 100 kilometers, so I'm going to move the decimal place 2 over. That gets me 11.63 liters per 100 kilometers. And the reason that we do that, like 100 kilometers, 100 grams, and all that, is just so that we can still see how many liters, but it's easier to read. It's just a whole lot easier to read 7.04 and 11.63 and compare those than it is to have a bunch of decimal places. That's all it is. They mean the same thing. And it didn't really tell you what to do here, but I think the point is to try to figure out which one has better fuel efficiency. And if I'm using 7.04 liters for every 100 kilometers, this one's using 11.63. This one's guzzling that gas. The other one, 7.04, is using less gas for every 100 kilometers. So car A is superior with fuel efficiency. That is it. Oh, thank goodness. I think that's it. You should have a stop sign here, and that is your cue to get your homework done. I'm not here, but I think your 2 homeworks that you were assigned for those stop signs, you should have those done definitely by Monday. So make sure you are using your class time. These are available online, the videos and stuff, if you need to do a review later or you need to get some practice. All right. See ya.